So we've talked about graphing lines. That's what we did in the previous section. We talked about plotting points and putting them on the Cartesian plane. We talked about picking specific points called the intercepts, and that works good. But the one caution I gave you is when the intercepts are fractional, that sometimes isn't the best way. So my next thing here in this section is I want to build up to a method of graphing that's going to be nice and quick and clean and works nice no matter what the equation of the line is. So before we do that, what we're going to do is we are going to talk about this concept. And this is the title of the section. This is section 2.2. We're going to talk about something called the slope of a line. Okay. Again, if you've had algebra at any point in the past, I am fairly confident you have seen this, but again, I am assuming nothing at this point. What the slope is it's our attempt to put a number on how fast a line is getting bigger or how fast a line is getting smaller. Okay, we're putting a number on this, and the slope is given to us. It's defined as a ratio. So let me do this on this grid. Let me make mine up. I'm going to pick just some point up here, and I don't care about the numbers. What I'm going to do is I'm going to call that point up there x1 and y1. And then I'm just picking 2 points that are kind of far away. There's nothing special about these 2 points at all. I'm going to pick another point down here in quadrant 3. I'm going to call that x2 and y2. So here I'm going to connect the dots. I'm just connecting the dots. It does not matter where your points are. That is immaterial. We're doing this in general because I'm going to give you a general way to calculate this thing called the slope. I want to show you what the slope is. So again, we didn't make this up. We inherited this, so we're going to go with it. The slope is given by this definition. The slope, and for whatever reason, historically in math, I don't know why, probably something to do with one of the languages that this was developed in, either French or Latin or Greek or something. The slope is given by the letter m. Well, let me ask you, because you've probably seen it. Does anyone remember the ratio of the two things that the slope is? It's something over something. Anybody remember? It's okay if you don't. Bam! Yes! Woo! I love it. Okay, so the slope, and in case you didn't know, is defined to be the ratio of how fast the line rises versus how fast the line is running. What is the relationship between those two things? So our rise refers to the y direction. Okay, I'm just making a nice dotted little red line. I kind of tore it up there at the end and it looks a little bulbous, but that's okay. The way you're going to calculate the rise is the difference between my y values. So I'm just going to take y1 minus y2. That's going to be my rise. I'm taking the top y value and I'm subtracting the bottom y value. Hey, Perkster, does it matter what order I do that in? And I'm just going to answer sorta, and I'll address that in just a minute. Okay. So my rise is given by y1 minus y2. My run is how far left and right the line is going. So I'm going to make a nice little dotted horizontal line left and right. And my run is going to be defined by x1 minus x2. Again, I'm going to take this point that's further to the right, and I'm going to subtract the point that's further to the left. And again, you might be saying, it doesn't matter what order. And my response is going to be sorta. There's my ratio. There's my formula. You do need to remember that. I try not to burden you with too many formulas to remember in here, but that is one of them, the formula for the slope. As far as the order goes, here's the thing to remember. Whichever point you make your first point and whichever point you make your second point, be consistent. So notice, I did y1. I started here on the right, y1 minus y2. So then with the x's, I did x1. I started with this point on the right minus x2. You could just as easily, and I could just as easily said y2 minus y1. But in that event, if I had started over here on the left, if I had said y2 minus y1, what do you think I have to do with the x's? Yeah, if I start with y2 minus y1, then I have to go in the same order with the x's. I have to do x2 minus x1. So the order you pick does not matter. What does matter is you have to be consistent with both the x's and the y's. That is what I am trying to bring out. So here's what we're going to do. I'm going to give us a couple of points, and we are going to find the slope between those. So I'll come back to my graph. I'm just going to grab a piece of notebook paper, and what we're going to do is this. We are going to find the slope between these 2 points. So find the slope. Uh-oh, my pen's running out of ink again. That's inconvenient, but we'll try again. And there we go. We're going to find the slope between these 2 points. My first point is 2, 5, and my second point is going to be defined by -1, -4. I'm making these points up. Uh-oh, we seem to be stuck. That's terribly tragic. We've done it. Okay. Yes, we are back. That's great. Okay, so I picked those 2 points. That's where they came from my imagination. And so what we're going to do is we're going to find the slope. We're going to find the rise over run between these 2 points. So my slope, my m, is going to be the difference between my y's over the difference between my x's. Now, what I'm going to do, I'm going to do this first problem two times just to show you that we will always end up with the exact same answer. And then you can do it however you want. So my slope, my difference between the y's, I'm going to do -4. That's the second point, minus 5. That's the first point. So if you were a -4 minus 5 person, if you looked at this problem and that's what you would have done, then what is your difference between the x's? What are you going to do? Yeah, -1 minus 2. Notice I've been consistent. I did -4, the point on the right, minus 5, and then I did -1 from the point on the right, minus 2. Or, okay, you don't have to ever do both of these. I'm doing it for this one example just to show you. Or you might be a let's go left to right kind of person. Now, I will just say be real careful when you're subtracting negatives. That's the one thing students miss. Students do great with slope on the test. This is the one thing, it's an arithmetic mistake. We're going to go 5 minus, and what am I subtracting? 5 minus what? -4, okay? So there's a subtraction sign, that's part of my slope formula, and then there's the negative in front of the 4, that's part of the point. And when I do 5 minus -4, I started at the point on the left, so then my change in my x's is going to be 2 minus -1. Either way, we will end up with the same final answer, so it absolutely does not matter whether you go left to right or right to left with your x's and y's. -4 minus 5 is -9. -1 minus 2 is -3. And that reduces -9 over 3 reduces to +3. 5 minus -4, that's the same thing as 5 plus 4. 2 minus -1, that's the same thing as 2 plus 1. And so 5 plus 4 is 9, 2 plus 1 is 3, and notice we get the exact same value. So if we're working any examples and you get the exact opposite of what I get, then you subtracted in the wrong order on either the numerator or denominator. So here's your chance. I would like you to find the slope between these 2 points. And your points are going to be 3, 2, and -5, 6. So I'm going to get started with my subtraction. So again, if you did your points in the reverse order I did, that's fine. Our final answer will match up. So my slope is going to be, I'm going to be a 6 minus 2 person. So I'm going to go from the right to the left. You might have 2 minus 6. That's fine. Then our denominators will be reversed. Since I went 6 minus 2, my change in my x's is -5 minus 3. Again, if you did it reverse, then you've got 3 minus a -5. 6 minus 2 is 4. -5 minus 3 is -8. I'm going to reduce that fraction of 4 goes into both the numerator and denominator. 4 goes into 4 one time. 4 goes into -8 -2 times. And my slope is 1 over -2. What this says, how we're going to apply this in just a minute, is that my line is always changing in this ratio. It's going 1 in the y direction, and it's going to -2 in the x direction. Okay, that's the ratio. It's going to be like climbing or descending steps when we get to it. But before we get to that, one more just to practice. I want to feel like a good professor today and make sure we're getting our practice in. One more pair of numbers. Find the slope between -1 and -7 and 4, 2. All right, doing my subtraction, I've got my slope is going to be equal to, and again, I'm just going to be real careful, and I'm subtracting a negative. My y's are 2 minus -7. Again, my minus sign's part of the slope formula. The negative goes with the 7. I do need both. My x's are 4 minus -1, same thing. The subtraction is part of the slope formula. The negative is part of the point. So in the top, 2 minus -7, that's 2 plus 7. In the bottom, 4 minus -1 is 4 plus 1. And so my slope is 9 over 5. So again, what that means is when we go to see the line, when we use this for graphing in just a couple minutes, my line is going 9 units in the y direction, and then it's going 5 units in the x direction. That is the ratio, and it never changes for the line. But before we get to there, and I'm real excited to get there because that's going to be very fun for us, I have one quick demonstration to do. And so here's my demonstration. Now that we've seen slope, we have a little bit of an idea, not a great idea, we're not there yet, but we have a little bit of an idea of what the slope is trying to tell me. I want to relate the idea of a slope to the equations that we were just graphing in the previous section. So what we're going to do, what I'm going to help you do, and then we're going to, you've probably, there's no mysteries here, I'm guessing you've seen this. We're going to find the slope of this line. And the line is going to be y equals, let's say, 4x minus 3. I'm going to pick a couple of x values. We're going to get 2 points so that we can figure out what the slope is, because we need 2 points to figure out slope. So here's my little table. And just because I love so much to plug in the x value 0, I'm going to plug in the x value 0. And then give me another x value. What's the other one you want to plug in? 2, sure, it doesn't matter. It'll all end up the same way. So when I plug in the x value 0, I get y is equal to 4 times 0 minus 3. 4 times 0 is 0. That's why I like to pick that. And so I get the y value negative 3. So x is 0, y is negative 3. The next one, the x value is 2. So I get y is 4 times 2 minus 3. So that is 4 times 2 is 8 minus 3. So y is 5. So hopefully that's not too much of a mystery. That's what we talked about last week, was finding values that are associated with other values. But what I wanted to do, and my whole purpose of this, is I wanted to find the slope. So my slope, my change between my y values, is going to be negative 3 minus 5. I started with the top value, negative 3, and then I subtracted the bottom one. So because of that order in my x's, I've got to start with the top value of 0, minus 2. Negative 3 minus 5 is negative 8. 0 minus 2 is negative 2. And I end up with, when I pop that into my calculator, 4. So here's the 50-cent question for you. This value 4, the slope, do you see that value in my original equation anywhere? Before the x, yes, and that is not an accident. That is not a coincidence. That's meant to happen. When you have solved your equation for y, the slope is always the number in front of the x. There's also bonus information here. When I plug in the x value 0, does anyone remember from the first thing we talked about today? When the x value is 0, what is this point right here called when the x value is 0? That would be, you're close. That would be if it was the equation was y equals negative 3, it'd be a horizontal line. But this particular point right here, 0, negative 3, had a name. Not vertical. It is the y-intercept. And again, that's not an accident. This number here that is added on, this negative 3, is the same as the y-intercept, and that is always the case. So what I'm trying to show you here is the link between our equations of the lines and slope. And so the link is this. This is called the slope-intercept equation. Again, math people are not super clever at naming things. It's called the slope-intercept equation because when you solve it for y, the slope is always in front of the x, and the y-intercept is always the number added on. So this is always going to be the slope. This is always going to be the y-intercept, which our book uses the letter B for. That's why I've called it B. And then it is solved for y. All right, so here we go. Now we're going to combine all this into a stew, and we are going to, we're going to use our equations, we're going to use our slope, we're going to use our y-intercept, and we're also going to create graphs at this point. So my first example, I'm going to do this one, and then you're going to have an example. My first example is going to be this. We're going to look at the equation y equals 2 over 3x minus 4. So this first equation, I'm going to work this one with you. I've given you the equation already solved for y. So first thing, the trivia. According to what I just told you about the slope-intercept, I'm going to put that trivia right here. It's in your notes, but it's right back here. What's the slope of this line right here? Perfect, 2 over 3. It's just whatever number is in front of the x is the slope. What is the y-intercept of this line right here? -4. I'm going to write that as a point so I don't go in the wrong direction. I'm going to write that as the point 0, -4. Before I graph it. That's our first skill of this section, or I guess our second skill. We found the slope by subtracting points. Our second skill is if I give you an equation, you can find the slope and the y-intercept. Okay, you just did that right there. It helped me through, and I'm going to give you one to do on your own in just a minute. Okay, so given that, now it's time to graph. So first thing, to graph it, my y-intercept, that is your point where you're going to start. So I'm going to go to 0, -4, 1, 2, 3, 4. So I make a nice point down there, 0, -4. And now it's just counting from there. The slope is 2 over 3. So help me out. The 2 tells me to go in what direction? Up. The y direction, up. And the 3 tells me to go in what direction? The x direction, or right, because it's positive. It's +2 over +3. So here we go. From my y-intercept, I'm going to climb the steps. I'm going to go +2 in the y, +3 in the x. So up 2, 1, 2, don't make a dot yet. 1, 2, 3, dot. Up 2, right 3, make a dot. I'm going to do one more time, having a great time. Up 2, right 3, make a dot. And there we go. There's my line. Boom. What I would like you to do, same thing I just did, I'm just going to change the line. Your example is going to be, I don't want to give you that one just yet. We'll talk about that in just a minute. Well, let's do this. We're going to do it in phases. How about that? Here is your line. Y equals -1 over 4x plus 2. I don't want you to graph it yet. I want to talk about the slope and y-intercept. I'm going to give you 30 seconds. I want you to determine what the slope and the y-intercept are of that line right there, please. Y equals -1/4 x plus 2. All right, what did you write down as the slope of this line? -1/4. So the question that I get every semester, and it's a fantastic question, and you might have it right now, is, Perkster, when I go to count off my change in my y, change in the x, where does the negative go? What's that? It depends. You're right, you're correct if you put it with the top. Okay, so you can do one of two things with the negative and -1/4. You can put the negative with the 1 in the top and have -1 over 4, or you can put the negative with the 4 in the bottom and have +1 over -4. It doesn't matter where you put it, but only put it in one of those two places. Because if you put, this would be wrong, don't write this down, but if you put a negative with both, -1 over -4, when you divide a negative by a negative, what do you get? Positive, and you've changed the sign of your slope. Okay, so you've got something new. So don't do that. Pick your favorite, put the negative with the top or the negative with the bottom. And then what's the y-intercept of this line? 0 what? 2. Perfect. Thank you. All right. So now what I would like you to do, I don't care where you put the negative, it's going to be the same line either way. I want you to graph what we've got. Okay, so here we go. I'm going to do both slopes. So whichever one you picked, you'll be able to see, but it's all the same line. So either way, your y-intercept is 0, 2. So I'm going to put a dot right there at 0, 2. And then if you put the negative with the top, that means the top represents which way are you going to move then? Yes, that's the y direction. And if the y direction is negative, that means you're moving down. And then 4 in the x is going to be moving positive or right. So if you did negative 1 over 4, then you went down 1, and then 1, 2, 3, 4 to the right. And down 1, 1, 2, 3, 4 to the right, and then connect your dots. But if you went 1 over negative 4, since the 1 is positive, you're now going to go which direction? Up. And since the 4 is negative, you're going to go which way? Left. You're going to go in the negative x direction. So this is up 1, left 4. So up 1, 1, 2, 3, 4 left. Up 1, 1, 2, 3, 4 left. So whichever way you went, do all of those points line up? Are they on the same line? Yes, they are. So it absolutely does not matter at all which way you put the negative. It all gives us the same line, and there it is. All right, here's another example for you. I would like you to do this. I want you to find the slope and the y-intercept, and then go ahead and graph y equals 4 over 3x minus 1. All right, what slope did you write down for this line right here? Perfect, 4 over 3. Y-intercept is 0, negative 1. Great. So the y-intercept 0, negative 1. I go down 1, and then 4 over 3 means 4 in the y direction, 3 in the x. So 4 in the y is 1, 2, 3, 4 up. 3 in the x is 1, 2, 3 right. Make a dot. 1, 2, 3, 4 up. 1, 2, 3 right. Make a dot. I encourage you to do a couple dots just to make sure you're counting right, because it's really easy to miscount, and I don't want you to lose points on the test for something silly like that. And there's my line. Okay, we're almost done with section 2.2. There's just a couple more things that we have to go through right here. So the next thing is this. Okay, every equation I've given you so far has been solved for y, but what happens if I say I want to know the slope and the y-intercept, and I want you to graph this? Negative 2x plus 4y is equal to 16. So negative 2x plus 4y is equal to 16. Well, before I can tell what the slope and the y-intercept are, please do not say on this one the slope is negative 2. I know I said the slope is always the number in front of the x, but the key caveat there is you have to solve for y. So before you can do anything with this line, what we have to do is we have to solve it for y. This is another one of those things that after you've done one or two, you're going to see that you do the exact same thing every time. So if I'm going to solve this for y, I have to get the 4y term by itself. So what has to be moved? Yeah, the negative 2x. How am I going to move this negative 2x from the left side over to the right? I'm going to add it. I'm going to add it. Great, great job. Thank you for the help on that. So the 2x's cancel, and I have 4y. On the right side of this, these things are not like terms, so don't say that there's 18 of something there, because there's not. What you have is 2x plus 16. So to solve for y, your first step is always going to be to move the x term, whatever it is, every time. Then, what do I have to move now to get the y all by itself? Divide by 4. Beautiful. That's always going to be your second step. It's always 2 steps. It's never going to be any more or any less. Okay, you're gonna move the x term, then you're going to divide. And so when I do that, here's the key. Maybe make a note of this to yourself. This is the most often missed thing. This 4 you have to divide into both terms. It's the distributive property. So first term, I've got 2 over 4 x. And then the second term is 16 over 4. Now, I haven't reduced, and I've done that on purpose. If you can reduce all in one step, then I encourage you to do that. But I just want to make sure in your notes, I've done everything I can to make sure this is clear. 2 over 4 reduces to 1/2, because 2 goes into both the top and the bottom. And then 16 over 4, your calculator will tell you that that is 4. So the slope of that line is equal to 1/2. The y-intercept is equal to 0.4. And at long last, finally, I am ready to graph that line. So I'm going to graph it by going to 0.4. That's my y-intercept. And then the slope being 1 over 2 means to go 1 in the y direction, 2 in the x direction. So 1 in the y, 2 in the x. 1 in the y, 2 in the x. And I'm just climbing steps. 1 in the y, 2 in the x. I could do this all day. It's very relaxing. And there is my line. So the reason I like graphing by the slope and the y-intercept is just because no matter what the line is, it shouldn't be too intimidating. It's manipulate it to solve it for y, tell me what the slope and y-intercept are, and then graph. Here's one for you, please. I'd like you to do this. I'd like you to do 2x plus 3y is equal to 9. So I want you to find the slope and the y-intercept of that, and then to go ahead and graph whatever it is you get. I'm just going to start solving this for y. So if you're graphing or if you're almost to that point, so same 2 steps to solve for y. First thing I have to do is I have to move this x term over to the other side. How am I going to move that 2x over to the other side? What operation? I'm going to subtract. Yes, indeed. Thank you very much. I'm going to subtract 2x from both sides. And so that cancels on the left. And then I have negative 2x plus 9. Again, those are not like terms. So don't say that there's 7x or anything, because that's going to be wrong. Second step is to divide by whatever's in front of the y, which I've just done. And then what I get is, in front of the x, I get a negative 2 over 3. And then 9 over 3 becomes 3. And there's my equation of the line. Y equals negative 2 over 3x plus 3. What's the slope of that line? That is indeed true, negative 2 over 3. What's the y-intercept of that line? 0, 3. Fantastic. That is great work. And so negative 2 over 3, again, you could put the negative either with the top or the bottom. It doesn't matter. Just don't do both. So my y-intercept is 0, 3. So I'm going to go up 3 and make a dot. Negative 2 over 3 means I'm going to go down 2, and then I'm going to go right 3, down 2, right 3, down 2, right 3. And there's my equation of the line. If you put the negative with the y, or excuse me, if you put the negative with the 3 in the top, then you just went up 2 and left 3, but we've got the same exact line. Okay, we've just got 3 last quick little things to do. The next is just another graphing example. Our book just wants to make sure you understand what slope is telling you. So instead of giving you an equation, I'm going to give you a slope and a point, and you're going to graph the line. So I want you to graph the line through the point 6, 8 with a slope of, let's say, negative 3 over 4. The only difference in doing this as opposed to what you did last time is, instead of having the y-intercept, you've just got another point, 6, 8. So you're going to plot that first, and then you're going to do the slope from there. Okay, so I'm going to go over to 6, 8. So 6 and then up 8. I'm going to make a dot right here. So instead of starting at the y-intercept, I'm just starting at this point that has been given to me. The purpose, the reason the book's doing this to us is just to make sure you understand what the slope is and what it's telling you. So now my slope is negative 3 over 4. Remember, we can either put the negative with the top, meaning I go down 3 and then right 4, or I can put the negative with the bottom, meaning I go up 3 and left 4. I gave this particular example just because sometimes where I'm kind of at the edge of my grid right here. So if I put the negative with the top, then I go down 3, 1, 2, 3, and then right 4, 1, 2, 3, 4. But then I don't really have the space to go down 3 and right 4 more. You can guesstimate if you like. So I need to kind of go backwards. So I've got 3 over -4. So that means I go up 3. And then 1, 2, 3, 4. I still have to guesstimate. I should have picked better numbers. You deserve better as a class. I'm sorry. And there we go. And there's my line. So I had to kind of put the negative in both places to get my 3 points. That was my purpose with that example, is sometimes you have to do that when you get toward the edge of your Cartesian plane. All right, that's I've got 2 last things to mention, and then you're free of me for another day. You're doing great. I appreciate it. We're going to revisit our special cases of lines. So let's say I have y equals 6, and then we'll talk about x equal to 5. And I want to now, since we've been talking about slope, how does slope relate to these special cases of lines? And then after this, I've got one more example that we're going to do, and we will be done for the day. So y equals 6. Remind me, we just talked about this today, so it's still in your short-term memory, hopefully. When you have y equal to 6, what kind of line is that? That's a horizontal line, indeed. Y equals 6, that is a horizontal line. If you need to make a table to determine that, remember that is totally good and okay. Well, here's what I need you to remember about a horizontal line and its slope. If I have a horizontal line, my slope is equal to rise over run. You told me that, okay? That was some prior knowledge some of you came in here with. Here's my question to you. As I trace this horizontal line from left to right, how much is this horizontal line rising? Yeah, it doesn't go up at all, right? There's no rise to this. Okay, so I'm just going to write under here, under the line, there's no rise. It's not moving up or down at all. So in my ratio, my fraction, the rise is 0. It doesn't matter what the run is. The run can be the run, any value. And in your calculator, if you take 0 and you divide it by any number, so if you have $0 in your wallet, you divide it among, let's say, 5 friends, how much money are you giving each friend? 0, okay? 0 divided by a number is 0. So a horizontal line has a slope of 0. Okay, we'll still review, probably easier to review since we just answered that question. If you have x equal to a number is what kind of line? Vertical, yes, woohoo! So once again, my slope is rise over run. Well, this time, my line is all rise. As I trace this line going up and down, how far is it running? How far left or right does this line go? It doesn't go left or right at all. Okay, so in this case, my rise is my line, my run is 0. Now, if you take your calculator and you take 5 divided by 0, your calculator is going to give you a funny answer. It's going to tell you that there's an error because dividing by 0 is undefined. And so as far as the slope, what we say is a vertical line has no slope. No slope is different than a slope of 0. Okay? No slope means there is no slope. There's no value to it. A slope of 0, 0 is the value. Okay? So those mean different things. Okay? So that's something to remember about our horizontal and our vertical lines. All right. You almost have made it. The last thing for today is 2 words. Yes. Go back here. Okay, sure. Yeah, thanks for slowing me down. I appreciate it. You good now? Everybody else good? Thank you for giving me the feedback. I appreciate it. All right, so the last thing for us for today that's related to slope, all of this has just been stuff about slope. is the idea of lines being parallel or perpendicular. What does that mean for us? Okay, so parallel lines. Does anyone know what it means if two lines are parallel? They don't touch. They're side by side like we hope train tracks are when we're on the train. Okay, those are parallel lines. They always stay the same distance apart. So in case you did not know what parallel lines are, they stay the same distance apart. So like any two, you can pick any two of the horizontal lines on your grid, we would call them parallel lines. Well, if two lines are going in the same direction and they stay the same distance apart, what that means is they have equal slopes. Perpendicular. Anyone familiar with the word perpendicular, what it means? They do cross, but they cross in a special way. Boom, yes. Perpendicular lines, they cross, you guys were right when you said that, but they cross at 90-degree angles. Just like on our Cartesian plane, the x-axis and the y-axis are perpendicular. Okay, they cross at a 90-degree angle. Now, this is not as intuitive as it might be. I think it's fairly reasonable to understand that parallel lines, since they're going the same direction, that means their slopes are the same. Perpendicular lines, their slopes are what's called negative, meaning you change the sign. Reciprocals, meaning you flip the fraction. So as an example, if I tell you the slope of a line is 2/3, what is its perpendicular? What's the negative reciprocal of 2/3? It would be what? Negative 3/2. You flip the fraction. So you have to do two things. You have to change the sign to negative, and then you flip the fraction to 3/2. So one more quick example. If I tell you that the slope of a line is negative, let's say negative 1/4, what is the slope of the perpendicular line? Positive 4/1. Yes, I changed the sign. That's what the negative means. So I'm just going to write a positive there for your notes, although we normally wouldn't. And then I flip the fraction to 4/1, which is just 4. When 1 is the denominator, we usually don't write it. So there's that. So here's our last problem for the day. And then you're done with me for another day. So you're going to be given at the end of this section the following question. Are the following lines parallel, perpendicular, or neither? And we're going to answer the question just by looking at the slope. So I'm going to give you two lines, and then I just want you to make as much progress as you can finding the slope of these two lines. I'm going to give you 3 minutes. We still got 10 minutes left in class. I'm going to give you 3 of those. I will finish up. You'll still get out a couple minutes early because I'm just that benevolent and generous. Okay, so the first line is 2x plus y equals 4. The second line is x minus 2y equals 11. You need to find the slope of both of those and then compare them to see if they are parallel, perpendicular, or neither. Okay, all we're doing here twice is what we were doing earlier when we were graphing lines. We're going to solve both of these equations for y, and we're going to look at the slope, and then we're going to determine the two lines will be parallel if the slopes are exactly the same. The two lines will be perpendicular if they are negative reciprocals of each other, and then neither if they are neither of those two things. So the first line, I've got to move the x term, so I'll subtract the 2x. The 2x's cancel, and I have y is equal to negative 2x plus 4. Those are not like terms. There's actually nothing to divide by on this. So what's the slope of this first line right here? Yep, well, I'm going to just differ with you on one thing. Okay, I'm going to go with the negative 2 over 1, but the x is not part of the slope. Okay, so don't write that down. That'll make your answer incorrect. The slope is a number. There's no variable. So it's negative 2 over 1. I will keep that. Yes. I appreciate you saying that because that is sometimes something students do. So please do not, if you wrote the x down as part of the slope, that is incorrect. There's no x, there's no variable with the slope. All right, the next one, I'm going to subtract the x from both sides. And I have negative 2y is equal to negative x plus 11. Divide everything by negative 2 this time. So what's the number in front of the x right now? Yeah, there's a 1 there. So it's a negative 1 over negative 2. Negative 1 over negative 2 becomes a positive 1 over 2. And then 11 over negative 2, a positive divided by a negative is negative 11 over 2. What's the slope of this line right here? Perfect. Thank you very much. That's awesome. Okay. Are those two slopes the same thing? Are they parallel lines? No, negative 2 is not the same thing as a half. You're right. Are they negative reciprocals? Are these perpendicular lines? I see one person. What do you get if you flip this fraction, negative 2 over 1, and you change the sign? You get 1 over 2. So these two are perpendicular because they are negative reciprocals of each other.